Circuit breakers don't actually use resistors to limit current flow. The common misconception is understandable because it seems like something must be there to prevent more than the rated amperage from passing through, for example, a 20 amp breaker. However, a resistor wouldn't be the right tool for the job. The typical circuit breaker employs a bimetallic strip. This strip is made of two different metals bonded together. When current flows through the strip, it heats up. Because the two metals expand at different rates when heated, the bimetallic strip bends. If the current exceeds the breaker's rating, like 20 amps in our example, the strip bends enough to trigger a mechanism that trips the breaker, interrupting the circuit. The reason resistors aren't used is primarily because of power dissipation. A resistor's job is to impede current flow, and in doing so, it converts electrical energy into heat. Think of it like a light bulb. A light bulb is a resistor that gets extremely hot and emits light. If a resistor were used to limit current in a 20 amp circuit, it would have to dissipate a significant amount of power as heat under normal operating conditions, even when the current is below 20 amps. This would be incredibly inefficient and would create a fire hazard. Now let's talk about why breakers sometimes fail. It's true that breakers need to be replaced periodically. While the bimetallic strip itself can degrade over time with repeated heating and cooling cycles, the primary cause of failure is usually related to the mechanical components of the tripping mechanism. The small latch, springs, and other moving parts can wear out, become corroded, or get gummed up with dust and debris. This can prevent the breaker from tripping when it should, or it can cause it to trip prematurely. Breakers are also sometimes damaged by repeated overloads or short circuits. Each time a breaker trips due to a fault, it experiences a surge of current and a mechanical shock, which can weaken its internal components. Essentially, it is not the case that the resistance element inside burns out because there is no resistance element inside. Instead, it's the mechanical components, the bimetallic strip fatigue, or the effects of repeated high current events that typically lead to circuit breaker failure.